Question, we see two groups of the same elementary mathematics course are taught by two different teachers. Teacher A and Teacher B. The final grades out of 100 of the students were recorded as follows. Assuming that the data is normally distributed and the standard deviations are equal between the two groups, conduct a t-test to see whether there is a significant difference in the average grades given by the two teachers using a 0.05 level of significance, or in other words, 5% significance. So first, we state the null hypothesis. Since we are talking about the final grades of this out of the 100 students, when using a t-test, we compare both variables. So let's go to number 4 in my paper. Okay, so therefore, our HO would be, there is no difference between the average graders, or the grades given. And this would also look like HO, we're gonna have like the equal sign, but it's really there's gonna be a, well, HO is equal to H1, or mu O is equal to mu1. It's the same thing. Okay, so for our alternate hypothesis, there is a difference between the average grades given. And this would look like HO is equal to H1, but it would be N equal. So it's N equal to H1. So it's gonna put something right here, or this right here. Well, we're gonna just put N equal. Okay, so when doing it on the calculator, well, I don't want to really explain how you do it on the calculator, but on the calculator, on the TI-84 Plus, we see that when finding T statistic, we get T is equal to 0.61 and P is equal to 0.547. So now that we have that, we write down the conclusion. To conclude, the p-value is greater than, or let's put greater than in there so that can be known, on a 5% level of significance, or significance. Therefore, we have enough. Oh, we fail. HO in favor of H1. Okay, let me explain. So since our t-test value is 0.61, that means that it's greater than 0.05 on a level of significance. When the p-value is greater than alpha on a 5% level of significance, we don't have enough evidence to reject HO, our null hypothesis, in favor of H1. That means that overall, there is a difference between the average grades given by teacher A and teacher B. Okay, on to the next question. So we have this. Menier owns and operates a pearl farm where he grows and harvests South Pea pearls and Tahitian pearls. Menier believes that the mean size of the South Sea pearls is greater than the mean size of the Tahitian pearls. Menier selects a random sample of each type of pearl and measures their diameters in meters. The results of these samples are shown in the table below. Menier performs a t-test at a 10% level of significance to validate his belief. It is assumed that the size of the pearls are normally distributed with equal variances. Okay, so first thing first, again, we're going to do the null and the alternate hypothesis. So for this t-test, we are comparing the mean size of the South P pearls and the mean size of the Tahitian pearls. So our HO would be the mean size of the South Sea pearls is equal to the mean size of the Tahitian. Let me write that better. And then our null hypothesis would be the mean size of South Sea pearls is greater than the mean size of the Tahitian. Okay, so find the p-value for this test using the calculator. Like I said, the TI-84 plus, we see that the p-value is 0.125. And then we're going to our conclusion to conclude the p-value is greater than, again, alpha, which would be on here. So let's put A right here, a big A, on a 5% level of significance. Therefore, there is not enough evidence to reject HO in favor of H1. So, like I said on the last time, the p-value is greater, so we don't have enough evidence to reject HO for H1, meaning the mean size of the South Sea pearls is equal to the mean size of the Tahitian, which is HO. Okay, on to the next one. We got question 12. At a horticulture lab, the sizes of Malus domestica, a type of apple, are studied to determine the effectiveness of the new fertilizer B in increasing the size of apples compared to the original fertilizer A. In a 200-meter yard, 20 apple trees are planted in 2 separate areas, 10 fertilized with A and 10 fertilized with B. At the time of harvesting, the researchers at the lab collected apples at a random from each tree and measured their diameters in centimeters. The data are shown below. Okay, so they're doing a t-test at a 5% level of significance. So our null hypothesis again would be HO, the mean sizes of the apples with fertilizer B is the same as fertilizer A. Okay. And then our alternative hypothesis would be the mean sizes of the apples with fertilizer B is greater than fertilizer A. No, I spelled fertilizer wrong, but it's okay. Fertilizer? Okay, A. Okay, I still spelled it wrong. Let me see. I don't know. If I still spell it wrong after that, then it's just gonna have to be it. Okay. So, using the calculator again, our t value is negative 2.43, and our p value is 0.0129. Let me make sure it's equal right there. So put equal. Okay, so the conclusion to this test, we would put to conclude the p-value is less than A on a 5% level of significance. Therefore, we have enough evidence to reject HO in favor of H1. Okay, so like I explained, if the p-value is greater than, we obviously don't have enough evidence to reject HO for H1. If the p-value is less than, we have enough evidence, and that means that the mean sizes of the apple with fertilizer B is greater than fertilizer A. Let me make sure H1 is known right here again, and yeah. So on to 13. Okay, so an investigation is undertaken into the annual incomes of two IT companies. A sample of 14 employees is taken from the company A, and a sample of 12 employees is taken from company B. To find out if there is any difference between the income levels of these two companies, a t-test is conducted at the 5% level of significance. It can be assured that the annual incomes of each company are normally distributed with the same variance. Okay, so let's write down the null and the alternative. So the null hypothesis, since we're comparing these two values or variables, the mean annual incomes of two IT companies are equal. That simple. And then we have H1, our null hypothesis, is the mean annual income of two IT companies are, the mean annual incomes of two IT companies are not equal. Okie dokie. So again, using a calculator, can't specify that enough. P is then equal to 0.0969. Okay, so we see that the p-value on what level of significance? We have 5, so the p-value is definitely greater than a 5. So to conclude, the p-value is greater than on a 5%. On a 5% level of significance. Therefore, we don't have enough evidence to reject HO in favor of H1. Okay, so like I said, I expressed that earlier, so that shouldn't be. Oh shoot, let me not go back to. Okay, did I delete it? It's all right. We wrote down, so even if it's deleted, we'll be fine. Oh, it's right here. Right here. This is supposed to be a conclusion right here. Okay, so determine whether the company should change the distribution of budget on advertising and media. Okay, we can do this on our own since I don't have that on my paper. Okay, so since we reject HO in favor of H1, we don't have enough evidence to reject HO in front of H1. So the mean annual incomes for two IT companies are equal. Therefore, the company should not change the distribution budget on advertising. Because both variables or both IT companies have the same amount, or have equal mean annual incomes, there's no need to change the distribution budget. Okay, on to 20 now. 20 is a little meticulous. Yeah, 20 is meticulous. 20 and 21. 20. So we have the call center at the Austin Police Department receives 100 calls for service from citizens every week. To determine whether the phone calls are uniformly distributed among the days in the week, a random sample of 147 calls are studied for their days of occurrence. The results are shown below. All right. To complete the table below with the expected frequency on the assumption that each should be equally proportional in calls received. Okay, so this is how we do it. We know that there are 147 calls studied for the days of occurrence. So when doing this, we must first, to find the expected frequency, we must put 147. We must times it by 1 over the 7 days, right? And that is going to give us 21. The reason why we do this is, well, that's how you get the expected frequency, because one day, each variable or each day should have the same amount, an equal amount. So we times the amount of calls by a fraction to get the expected amount for each day, and that's 21. So just imagine this table is filled with all 21, because I can't do it on this side. So HO, back to it. The phone calls are uniformly distributed. H, the alternative would be the phone calls are not uniformly distributed. Okie dokie. Okay, so now we have to determine our degrees of freedom. Degrees of freedom is basically content minus 1. So we see that there's 7 days. We do 7, that's 7 categories, and we subtract that by 1, which gives us 6. Okay, so using graphics display calculator, we would put in the degrees of freedom, and then for these two tables, we would use stat, and we would edit. I don't know if you can see, we would edit, and then add both days, the day and the expected frequency in L1, L2, and then we'll go to GOF, we'll go to GOF, and then we'll put the list 1 and list 2 will transfer over, and we'll put the DF, the degrees of freedom, to find the answer. So using the TI, I got that chi squared is equal to 2.95, right? Okay, so chi squared is basically, it's the same as a t-test, except these are 2. When we're doing GOF, we're determining whether or not they are independent or dependent from each other. Or in this particular case, it's normally are distributed. Are they distributed correctly? Or uniformly distributed? But the critical value, when we're determining the critical value, is the same as P, right? If the chi squared is less than the critical value, we do have enough evidence to reject HO for H1 if I'm correct. Yeah. Let me see. Yeah. So this is how our conclusion would go. To conclude, chi-squared, sorry, getting them confused already. The chi-squared value, or test value, let's put test value here. Test value is less than alpha on a 5% level of significance. Therefore, we have enough evidence to reject HO in favor of H1. All right. Therefore, we have enough evidence to reject HO in favor of H1. So that's the end of that. And on to the last question. It's going to be the same thing. Okay, so now we have 180 customers on a random day. So we already know 180. We times that by, we have 6. We have 6 categories. So we do over 6. And doing that, we figure out that the answer is 30. So the expected frequencies for all cashiers is 30. Okay, so state the null hypothesis. So the null hypothesis is the customer's selection of cashier here is uniformly distributed. Uniformly distributed. Okay. And our alternative hypothesis is the customer's selection of cashier is not uniformly distributed. Working as I go, of course. So like I said, with the degrees of freedom from the last section, we have 6 categories. We do 6 minus 1, and that is 5. Sorry, degrees of freedom is 5. Put in the calculator, and what we're going to get is x is, or chi-squared is equal to 3.53. So we also see that it's less than, so it's going to be the same as the last one. So we're going to put to conclude the chi-squared test value is less than alpha on a 5% level of significance. Therefore, we have enough evidence to reject HO in favor of H1. And that is it.